Hello and welcome to Kanai's AI Lab. In this video, we dive into AI-powered sports analytics, specifically focusing on detecting and tracking a cricket ball while Virat Kohli plays his signature cover drive. We will utilize YOLO, which is a state-of-the-art object detection model to detect the ball in each frame of the video. So traditionally, we know that computer can process only numerical data. However, with the rise of artificial intelligence, the machines can now interpret speech, image, videos, etc. In this case, we use AI to detect and track the cricket ball, which helps players and coaches to analyze the performance more effectively. So before we moving into the code part directly, we want to understand two techniques. So one is image classification and another one is object detection. Image classification identifies if the object is present in the particular image. For an example, we have an image here where there are three classes. I can see cat, dog and ball. Basically, the machine is identifying which is the class or label of that particular object, either ball or dog or cat. So this is called image classification process. On the other hand, the object detection, which is an extension of image classification, so it will identify images. Definitely, it will identify the classes like cat, dog, or ball, and it provides location of the object present in this particular image. Specifically, it will be providing a coordinate system like square boxes, like we call it as a bounding box. So we can see here bounding box for ball, bounding box for cup, etc., etc. Which basically, where is the cricket ball in this frame? I can see the ball is here. I identified which type of object it is. It is a ball, and along with that, it locate where it is using the bounding box. So we will be performing to identify cricket ball tracking in real time. For that, we need some libraries. Let me execute this because it may take some time. So we are installing the libraries that will be used, basically the libraries for image processing, video manipulation, and object detection. So we will be using pip install option for OpenCV, NumPy, TensorFlow, Keras, and Ultralytics. So we will be needing OpenCV Python, which is the library for working with images and videos in Python. Basically, it allows us to read, manipulate, and display video frames. So we know what is NumPy. NumPy mostly handle the arrays and numerical operation. So we need image processing, which is in array format now. We also need TensorFlows and Keras, which is basically a deep learning task. Although we don't use directly TensorFlows and Keras in this case, but they are very powerful to modify the YOLO model, or if you want to work with some custom models. So we will be needing the Ultralytics. So Ultralytics is the library, which is the very powerful library, which contains a YOLO model and which is used to perform object detection on video frames. So let us wait for the complete loading of this library. We can see that one by one libraries are going to install. So one by one is installing. Let us wait for another 3-4 seconds. We are expecting to complete the complete installation in another 5 seconds. Let's wait for that. Still running only, unfortunately. Once the run is completed, the buffer will convert it into tick mark. It's taking more than usual time. Don't know why, whether we are getting good runtime on the CPU. No issues. We need the libraries to be successful in installation. Otherwise, there may be so many errors will be thrown. Okay, you can see that this installation complete. So next we are going to run this particular script. What is this? This is nothing but mounting Google Drive to access the video file stored there. So for that, this prompt will authenticate and give Google Collab to access your Google Drive. So it will be asking some conditions. So what is your Gmail? And after that, it's asking the policies to accept. So once the policies are accepting, it takes another 1 or 2 seconds to get the drive. I can see the mounting is happening now. So after the Google Drive mounting completes, we will be running our video, which is the raw video available with us, where we are going to track the ball. So this mounting is completed. Now we will be showing the video, which is nothing but Virat Kohli cover drive, which is available here. Let me make it run here and we'll be playing in the full screen mode. This is the video. I'm very sure you all will enjoy this Kohli signature cover drive shot. With that, we will be moving to our code. So as we know, we are going to perform this ball tracking activity by using YOLO. So which is you look only once. So YOLO is a real-time object detection algorithm that processes each frame of a video in a single pass through a neural network. It detects the object by dividing the frame into grid and predicting the bounding boxes, class probabilities on the video or images. So this model is trained almost around 80 plus objects like person, car, household items, animals, etc. But it can easily expand into custom objects like training by using the YOLO. So you can see here, we have an image with the 2 objects present. So we are telling machine to identify. So there is a dog and there is a cycle. So the first, this image will pass through the grid. We can see that image is divided into number of grids. And after that, the algorithm identify what is the class of the object. In this case, I can see dog. And what is the class of the another object, another cycle, another car. Once the image is identified, it will locate the position using the bounding box. I can see that after labeling, it clearly defines the location of the object present in the image. So with that, we will be moving to loading the required libraries once again. So we installed the Ultralytics. Now we are going to take YOLO from Ultralytics and calling a name called YOLO underscore model. We can see here YOLO.8 we are going to use in this particular case. And also you are taking YOLO from Ultralytics. So with that installation and library, we will be moving to our real-time activity, which is nothing but ready to detect the ball's location in the frames, which is by YOLO. So let me execute this step. You can see here, this is the code for the entire activity. Let us see the output first. I can see this still running. Yeah, the output starts coming. So let us wait. This is called frame per second. We have defined each and every second there must be 30 frames. And each and every 30 frame, I'm having the enough information. What is the bounding box and which is the objects and what is the processing speed, everything we have. So we have all the information about this particular video, converting into multiple frames and tracking in each and every location. So you can see one by one. Let me see here. Yeah, you can see generating many frames. You can see green color bounding box. Once the green color bounding box, you can see the notation started. This is called labeling. And the green color box, we'll call it as a bounding box. And bounding box coordinate is actually shown in the bottom of the picture. And what is the object name, which is mentioned again, one sports ball. I can see still tracking is there. I can see each and every frame, the tracking is happening. So this is all about the process. This will happen for throughout the 12-second video. Now let us see how we can able to do this particular process. Let us understand in just 2 to 3 minutes how we created this small technique of tracking the ball. So first, we start calling the library. So what are the library we use? I use CV2. CV2 is nothing for video processing, and I use CV2 IM show for displaying the frames in the collab. So after that, we defines the input video path, we defines the output video path and the frame dimension of 640 and 340. After that, we define what is the video writer? We will be using cv2.videowriter function to create an output video where we process the frames will be saved. And also you can see here, we clearly defined we need 30 frames per second. So after that, we are defining a variable called tracker, which is set to none. And also we defining another variable which is tracking, which is a Boolean flag used to indicate whether tracking is active or not. So after that, we will be using CV2 to video capture. So we will be passing the video path in this case, and which will be frame for each and every frame. You can see that after that, there is a while loop, which runs through each frame of the video. And if no frames is identified, mostly at the end of the video, the loop is going to stop. Next, we are resizing each of the frame to a fixed resolution to maintain the consistency during detection and tracking. So we will be moving to the another important step, the YOLO model. The YOLO model is applied to the frame and returning the bounding boxes. You can see here x1, y1, x2, y2, and also the class IDs. Where is the class ID? You can see the class IDs. And also you can identify what is the confidence scores. This is we are defining using the for loop. And if the loop is not identified, and also you can see here, this can be identified with if the loop is having 50% confidence score. So we are giving a threshold. So it identified an object by using a class ID, and we are defining a number 32 to the ball. If the ball is identified with a confidence of 50%, what is going to happen? It is creating a bounding box coordinate. You can see here bounding box coordinate will be creating, and which can be extracted for the further use. So this is already done. And next case, initially, once the ball identification, one time it is actually captured the ball. Next, we need to identify whether the tracking is started or not. If the tracking is not active, we will be using a channel which is nothing but CSRT, which is initialized using the detected balls bounding box. We can see here in the previous case, we identify which is a ball, and once the identify, we say that the class is 32, which is meaning to be a ball, and we check whether the confidence interval is more than 50%. If that condition satisfied, we will be creating the bounding box. Once using the bounding box created, we will be checking the tracking started or not. If not started, using the same ID, we will be initializing the channel CSRT and continuing the tracking. So then the process frame is displaying using the CV to IM show, and also it's returned to the output of the video file. Once the processing is completed, what is going to happen? The video file and output writer are released in this case, and also OpenCV windows also released. Finally, we will be printing a confirmation message that the process video has been successfully printed. I can see here in the picture once again, all the frames are generated. The ball, that is ID, is objected. Once the ID is objected, the bounding boxes are created in each and every frame. Now, some cases you can see here, there are sometimes no ball, sometimes there is a ball, but which unfortunately cannot able to identify. You can see in this particular cases. But in the later stage, I can see some cases it is identifying properly. So it is a truth that we may not be able to track in every frame of this particular video. The reason might be the speed of the ball, or it might be the clarity of the picture, or it might be multiple objects present in that particular frame, or chance is that the ball size is very small compared to the frame. So maybe these all reasons we may not be able to track the video continuously in each and every frame, but still we made a decent tracking to identify where the ball is on the video. So with this, we are concluding this video. This is a powerful example of how AI is revolutionizing in sports analytics by automating complex tasks like object tracking. And this method can be extended for further uses in cricket, such as You can make this for LBW decision, tracking whether the ball hit the bat or pad. So also this can be extended, checking if the ball reached the boundary or not. Also understanding the ball trajectory for player analytics. For simplicity, we focus only on tracking the ball position throughout the video. I hope you enjoyed the video. Thank you once again for watching Kanai's AI Lab. Stay tuned for more exciting AI videos.